did was multiplying it to put together the polynomial. Today we're breaking down the polynomial. So we're going the other direction. And if we're breaking it down, that means that we're doing some synthetic, right? We're finding some zeros and some fun stuff. Okay. So, first thing I want to remind you of, so quick reminder, is of the fundamental theorem of algebra. In the fundamental theorem of algebra, we had to first find at least the number of zeros to reduce the polynomial to a quadratic. Right? So if our highest exponent was 5, we had to find 3 zeros, right, to get it down to a quadratic. If our high exponent was only 3, we had to find 1 0 to get it down to a quadratic, right? All right, so then step 2, we did synthetic with the zeros. Step 3, then we solved the remaining quadratic function we have. And we can solve it in many, many different ways. One way was the quadratic formula. Yeah, or another way was factoring, using our x and our box if necessary. Or, if there was no b term, what else could we do? The square root method, right? So we had those 3 options in order to solve once we got down to a quadratic. And you could use whichever one you liked the best or whichever one worked in the situation. So, I want to remind you of how this went down. So example number 1. Find all solutions. And let's start off with, how about y equals x to the 4th? Plus x to the 3rd. Huh? Plus 5x squared. Minus x minus 6. Okay. All right. So here's our polynomial. How many zeros do we have to find to begin with? We got to find 2, right? Because there's a total of 4, but we got to find 2 zeros to get this down to a quadratic. How do we find those zeros? No, now we do the rational root theorem. Rational root. Take all the factors of 6. 1, 2, 3, and 6 over all the factors of 1. So, we have plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. We have to find 2 zeros out of those 8 so we can get started. Now, we all agreed last year that the easiest way out was to do what? Yeah, we graphed it. I mean, we can take all 8 of those, plug them in, and find out what makes it 0, or we can graph it. What do you want to do? Graph it. Okay. All right. What did you get, Nick? All right. So we got x equals -1 and x equals +1 is the 2 zeros. Does everybody else get the same thing? All right. So now we're going to do synthetic. In our synthetic, yeah, when you graphed it, where does it cross the x-axis? So when you graph this, this crossed at both -1 and +1. So then we're going to do our synthetic. Our coefficients go across the top. 1, 1, 5, -1, -6. Let's start with -1 out here. Bring down our 1. -1 times 1 is -1. We add them together, we get 0. -1 times 0 is 0. We add it together, we get 5. -1 times 5 is -5. We add that together, we get -6. All right, I'm going to put an X there for no remainder. Then we're going to continue leaving it still in the same box, and we're going to put our next 0, which is a 1. Going to bring down the 1. 1 times 1 is 1. Add them together. 1 times 1 is 1. We add them together. 1 times 6 is 6, and no remainder. So the quadratic we have left is 1x squared plus 1x plus 6. Now we have to solve this one. Does this one go into the box, or into the x? Does it factor? No, it doesn't, does it? Okay, which means we're going to have to do the what? Quadratic formula. So, our a is 1, b is 1, and c is 6. So, negative b plus and minus the square root b squared minus 4 times a times c all over 2a. In here we have 1 minus 24, or negative 23. Do you guys agree? So if I have the square root of negative 23, what can come out of there? Okay. I, thank you, Braden. That's perfect. I, square root 23 over 2. Can I reduce that or simplify it at all? Nope. So I have x equals, there's 2 of my zeros, and then of course we have plus and minus 1 as my other 2 zeros. So looking at this, some of our questions we're going to have today is going to ask you, first of all, how many zeros should there be? 4, right? Because our highest exponent was 4. How many of these zeros are real? 2. So you have like 3 questions where I ask you how many you're supposed to have and how many are real. And it's real if it crosses the x-axis, right? And that's it. So you guys remember doing this. You guys loved doing this back in Algebra 2, didn't ya? Say yes, we liked it. Okay. All right, so let's get to something fun and new and exciting. Something fun, new, and exciting. You ready? All right. Yeah, example number 2. So, let's say you have... thinking. Let's say you have y equals x to the 4th plus 13x squared minus 48. Okay? And I tell you that one of your zeros is at x equals 4i. Okay? What I want to know is, what are the other ones? Okay? So first of all, if you have 4i, you also have what? Negative 4i. Very good. So we're going to do this by synthetic. Okay? Now, I know I told you before, when we do synthetic, it's only if we have zeros. Well, we do have a 0. Granted, it's got an I in it, but we're going to have some fun with it. So, in synthetic, our coefficients are 1. What do I put for x to the 3rd? 0. Then I have 13x squared. What do I put for x's? 0. And then negative 48. Okay. So I'm going to put a 4i out here. All right. In synthetic, we bring our first one down. Then we multiply. 4i times 1 is? Good. And we add these together. 0 plus 4i is 4i, right? Now, what's 4i times 4i? Yes, it would be 16i squared, which is negative 16. Add these together. What do I get? Good. Now Now we multiply. 4i times negative 3 is negative 12i. Add those together is negative 12i. 4i times negative 12i is negative 48i squared, which is 48. No remainder. Now, if we had 4i, we said we also have to have negative 4i. All right, so let's do negative 4i. Again, that's going to get us down to a quadratic, and we'll be able to solve it from there. So I'm going to bring down my 1. Negative 4i times 1 is negative 4i. 4i and negative 4i, that's 0. Negative 4i times 0 is 0. Add these together. Negative 4i times negative 3 is positive 12i. Add them together, no remainder. What do we have left? All right, and what's going to be the easiest way to find our last two solutions? Yes, let's set this equal to 0. I'm going to add 3 to the other side, so I have x squared equals 3, which means x is also going to equal plus and minus the square root of 3. So, 2 of our zeros are at plus and minus the square root of 3, and our other 2 were at plus and minus 4i. So it wasn't so bad, right? So, looking at those answers, first of all, how many zeros do we have? 4. How many are real? 2. Very good. Okay? Shall we try one a little harder? All right. So here is example number 3. And your directions are going to say, using the given 0, maybe. Where is he? Oh. Using the given 0, find all zeros of the function. Alright, and let's go with f of x equals x to the 4th minus 2x to the 3rd minus x squared plus 6x minus 6. And we have a 0 at 1 plus I. You're close. It'd be 1 minus I, yes. So it's plus and minus, right? Goes in the middle. All right. So we're going to have some fun with this. We're going to try it in synthetic. So coefficients across the top. 1, negative 2, negative 1, 6, and negative 6. We have a 0 at 1 plus I. That looks like fun, doesn't it? So let's bring down our first one. 1 plus I times 1 is 1 plus I. Add these together, what do we get? Yep, negative 1 plus I. Now this is where the fun begins. 1 plus I times negative 1 plus I. So we have to put it in the box. So we have 1 plus I times negative 1 plus I. Negative 1 times 1 is negative 1. Negative 1 times I is negative I. 1 times I is positive I. I times I is I squared, which is negative 1. So in this box, what do we end up with? Negative 2. Add these together. We get negative 3. All right, now we got to multiply. 1 plus I times negative 3 is negative 3 minus 3I. taking this negative 3 times 1 plus I, which means we have to do the distributive property, right? We have to multiply everything in there. Okay, so now if we add these together, 6 plus negative 3 is 3 minus 3I. So now we have to do a box again. If we do this box correctly, can anybody predict what should happen? Should get a positive 6, right? So we have 3 minus 3I times by 1 plus I. Yes, you have to do it. 1 times 3 is 3. 1 times negative 3I is negative 3I. 3 times I is positive 3I. Negative 3I times I is negative 3I squared. Makes it a positive 3, which gives us 6. So we have no remainder. However, we get to do this again with 1 minus I. Because look at, we have i's in our polynomial. We can't have that. Alright. Stop. Alright, so again, I'm going to write down here just so we have like a clean slate to work with. I have 1. I have negative 1 plus I. I have negative 3. And I have 3 minus 3I. And my next 0 is 1 minus I. Alright, so the first thing I do is bring down the 1. 1 times 1 minus I is 1 minus I. Add these together, what do we get? 0. Okay. 1 minus I times 0. Add these together, we get negative 3. 1 minus I times negative 3. Yeah, so we have no remainder. What do we have left? X squared minus 3. And again, to get our last two zeros, we set this equal to 0. And we get x equals. Yeah, so this time we have plus and minus square root of 3. And 1 plus and minus I. So we again had 4. 2 of them were imaginary, right? 2 of them were real. That one wasn't so bad, was it? Oh, you guys, you have such a long year to go. This is some fun stuff. All right, so here's what I want to do. All right, here is example number, what am I on? 4. This is actually going to be in the first section, 22 through 26. Just trust me. 22 through 26. The directions say state the zeros and the number of real zeros. And you are given f of x equals x to the 5th minus 2x to the 3rd. Oh, sorry, second, my bad. Second. Minus 3x plus 6. So, how many zeros should we have? We're just stating how many we're going to have. That's it. Okay? So, how many total zeros should we have when we're done? Both real and imaginary. 5. Okay, so we're going to have 5 zeros, right? Okay, then I need to know how many real. So, all I'm going to ask you to do is graph this. Tell me how many times it crosses the x-axis. Alright, so you should have gotten a graph that kind of looks like this, right? So it crossed the x-axis one time. So how many real zeros do we have? 1 real. That's all you have to do for 22 through 26. Okay? Example 5. How did I get tangled up here? There we go. Example number 5. Example 5 is 28 through 32. It says find all of the zeros and write as a linear factorization. Alright, so what that means is after I get my zeros, I'm going to write it out as factors and not just as x equals blah, 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 and blah. Okay? So, let's say in this one, we have f of x equals x to the third minus 10x squared plus 44x minus 69. Alright, so we need to figure out how many zeros before we can find the rest of them. How many zeros do we have to find the rest? We have to find a total of 3. How many do we have to start with? 1. Why 1, Braden? That's true. That's true. We got to get it down to a quadratic, right? Okay. Got to get it down to a quadratic. So we need to know all the zeros. Now, what's the easiest way to find our first zero to work with? Graph it. So graph it. Tell me where our first zero is at. 3? All right. Carly says 3. So now we're going to do synthetic using 3 as our zero. Okay. We're going to bring down our 1. 3 times 1 is 3. Add these together, we get negative 7. 3 times negative 7 is negative 21. Add these together, we get 23. And 3 times 23 is positive 69 with no remainder. So left, we have x squared minus 7x plus 23. Does this factor? Are there factors of 23 that will give us negative 7? I don't think so either. So guess what? We have to solve it by the quadratic formula. That's right. So remember, your A is 1, B is negative 7, and C is 23. So we have negative B, so positive 7, plus and minus the square root, B squared, minus 4 times A times C, all over 2A. Negative 43? So we have 7 plus and minus. Do you agree? Plus and minus. Oh, if it's a square root of negative 43, what can I take out of there? So I square root 43 over 2. Now, here's the thing. We found all our zeros, right? We found all 3 of them. 2 of them are imaginary, 1's real. But the question said to write it as a factorization. Oh, that's okay. Okay. You got it. I'll have it all ready for you. So as we write it as a factor, remember that first factor that we had as a 0 was 3. How do I write that as a factor? X minus 3. Then for our next 2, we have x minus, and then you can put it, you can put it all in like one group together. So I'm going to put it like this as 7 plus and minus I root 43 all over 2. Well, because it has both the plus and minus. You can write it with the plus, and then you can write it with the minus, so you can put them together. It doesn't matter. Okay? It's up to you. But this is what they mean by a linear factorization. Okay? Okay. 36. In this one, it says using the given, oh, come on, there we go, 0. Find the rest. And then they want you to write it as a linear factorization, blah, blah, blah. Okay? So we're going to write it as a linear factorization afterward. And let's say that we have f of x equals x to the fourth minus 2x to the third plus 5x squared plus 10x minus 50. And you have a 0 at 1 plus 3i. If we have 1 at 1 plus 3i, we have 1 at 1 minus 3i. All right, we're going to do it by synthetic. Coefficients are 1, negative 2, 5, 10, and negative 50. Our 0 we're going to start with. We're going to do 1 plus 3i. Going to bring down our 1. 1 plus 3i, or 1 plus 3i times 1 is 1 plus 3i. Add them together, I get negative 1 plus 3i. Now we're going to multiply them. So we have to multiply them in the box. 1 plus 3i, yes? Awesome. Thank you. And negative 1 plus 3i. Negative 1 times 1. Negative 1. Negative 1 times 3i is negative 3i. 1 times 3i is positive 3i. So that diagonal canceled, right? 3i and 3i is 9i squared. What do we get for this box? Negative 10. All right. Add them together, we get negative 5. Now when you multiply 1 plus 3i times negative 5, you have to do what property? Distributive property. Good. Perfect. Negative 5 minus 15i. Add them together, we get 5 minus 15i. So when we do this last box, we should get what? We should get 50. Okay? Now, you know, after this, the next one's easier because everything drops out. So we're going to take 5 minus 15i times by 1 plus 3i. 1 times 5 is 5. 1 times negative 15i is negative 15i. 5 times 3i is 15i. So our diagonal cancels. We're doing great. 3 times negative 3i times negative 15i is negative 45i squared. So it makes it a positive 45, so we get 50. Imagine that. All right. So now, again, I'm going to rewrite that so you have a clean slate down here. We have a 1. We have negative 1 plus 3i. We have minus 5 and 5 minus 15i. Out here, I'm going to have 1 minus 3i. Bring down our 1. 1 times 1 minus 3i is 1 minus 3i. Lo and behold, what happens? Cancels out, just like it did before, right? 0 times that is 0. Add them together, we get negative 5. Yeah, negative 5 plus 15i, and it cancels out. So we're left with x squared minus 5 equals 0. What are our last two zeros? Good, plus and minus root 5. All right, so let's write these as a factorization. This is I'm totally good with. You ready? X plus and minus root 5 and x minus 1 plus and minus 3. Was it 3i? Yeah. I am totally good with you writing it that way. Okay? Any questions? Alright, so then the last couple problems, you're really just dividing by one factor and you're done. Do you want me to go through one example of that? Braden says no. Michael says no. Anybody else? Do you want me to do one more example? Are we good to go? We're good. Alright. Do you guys have 12 minutes or so?